This is the group presentation for CIT260 for Brother Jones's class. We have Miriam Erickson, Laura Friedman, and Braden Harada. The functional development process has 7 steps, and they are as follows. Step 1, clearly understand and define the problem. Here we have the inputs, task, and output.
And for our team function that we did calc resources left, and we have 3 inputs, 1 output, and then we have the validation rules defined.
Step 2, here we have the test matrix.
And in the test matrix, it's testing for the valid, invalid, and boundaries for the variables within the function for our calc resources left.
Step 3, outline the solution. Here we have pseudocode.
And within the pseudocode, we also have, aside from testing for the valid, invalid, and invalid cases from the test matrix, where we also in the pseudocode have any calculations or any other code that are statements that we feel the function requires.
Step 4, test the algorithm. Here we use the values directly in the test matrix to verify and validate the values of the pseudocode. Step 5, translate the algorithm into Java code. Here, we take the pseudocode and put it into NetBeans so that we can see what the code looks like exactly as it should be, so that the computer can understand it. Step 6, run all test cases.
And in this particular example, we're showing just the first 2 test cases from our team function that we did. The first one is for all valid variables with an expected result of 20. And then on the second one, we have where the start amount is too low. So the start amount has to be greater than 5. And that should return an error value of -1. That's what we're expecting from this particular example.
The last step, number 7, deploy code changes to GitHub repository. Here, we commit our changes so that we can know exactly what we're uploading. We pull and merge from the GitHub repository to our local repository. And then once we have those changes merged, then we push from our local repository up to the GitHub repository so that everybody can see the changes.
Okay, so here we have selection statements that in Java, and I'm going to show the if-else statement. I used a new random function, and the if-else statement only allows if you use that when you want to have you're checking for 2 different things. So in this case, I am having the user, they will input a number between 1 and 10, and the number that they input will determine which statement is printed, whether it's an it worked statement or an it didn't work. If it's a 1, 2, or 3 that's entered, that statement will say it worked. And if it's anything from a 4 to a 10, then it will output it didn't work.
And the Java selection statement that I'm focusing on is the if statement by itself, and that is where you really have just a simple, you're only checking for one situation, one circumstance, and it's not a complex selection statement. It's the simplest one you can have. So in this particular case, it's if not character. I'm checking to see if what the user inputted, one character that the user inputted is a letter or a number, and if it's not checking if not letter, then it's returns false. It's an invalid value. If it is a letter, then it returns true. So that is a very simple way to get a quick check on something.
The selection statement that I chose is the switch command. This statement is used for multiple options to compare certain values. In it, there are cases. If a case is met, the function runs that case and will stop at the breakpoint, and then it'll continue on in the function. If the case is not met, the function will skip to the next case.
And the value of a switch statement?
The value of a switch statement, it's basically looking for each individual case. In this one, the case O, if it sees...
Well, I'm more focused on when we use a switch statement when there are a lot of things that you want to check for. And that's when we use it.
So for efficiency.
For efficiency, for speed.
Mm-hmm.
Okay.
And here's where we're talking about our control function unit test for our individual assignments.
And I have advanced along the trail as my function, and this goes through and shows the valid inputs that I have. And then there are actually 13 additional invalid cases with the input either being with one of those being invalid, and the outputs as shown below correspond to those.
And for my individual assignment, I did calc resources needed, and there are 10 valid, invalid cases that I'm checking for. Here's valid, and then here are the invalids. Mostly minimum, maximum, and that's it.
I chose to do the calc just to next. Basically, we're going from our current coordinates to our next stop coordinates. And in it, I have the valid coordinates for current and next stop. And then I have also test cases for invalid, as well as I have the boundary limits.
And now we're going to go and run that code. Miriam?
Okay, so we have the test for the advance along the trail method or function, and showing the output, the first one showing the valid output with all valid variables, and then the following test cases have invalid out results for those.
And then test calc resources needed is my function, and I test for 10. According to the test matrix, there's 10 test cases, 1 valid and 9 invalid. And as you can see, here is the here are the 10 cases that I'm testing for. 5, 7, 9, 10.
Here's mine, and mine is the test for the calc just to next. And in it, I've got test case 1, which is all valid variables. And then I've got test case 2, in which the current coordinates and the next stop coordinates cannot be equal. And then I have test case 3, 4, and 5, and 6 for all the other invalid inputs.
And just to kind of emphasize that in the test case code, we're checking for, we put in what's in the test matrix and then specifically what should be returned from the function. The expected result is, in this case, for the last part of Braden's function would be a -5 would be returned. So now we're going to run this code. And open the test results window. And as you can see, the test passed 100%. And here's all the functions and their test cases, and they've all run successfully.
Woohoo!
Yeah, woohoo is right.
So here we cover the scope and lifespan of the variables. I'm covering the class variables. In it, basically, because this variable highlighted in yellow is a private string, this class variable is specific to this class. So the scope is class specific. It won't go outside of this class. No other class can reference this specific variable. And the lifespan of the variable is within the class as well. So once the class is still in memory, then the variable itself is still alive and functional. Once the class is no longer in memory, the variable goes with it. To reference this variable, we use this dot. In this case, it's journey time message.
So for each instance of an object of the class, it would have these variables.
Yes, in each instance of the class.
And I'm going to talk about function variables. And function variables, the scope of them is within the function themselves. So if this function is within the class that Braden spoke of on the last slide, but these function variables are only within the function. They're not within the class, so they can only be utilized within this function, and their lifespan is only while this function is running. So once this function is finished and this statement return value is executed, or it aborts for some reason, then the variable is no longer, it's terminated. The life is terminated for that variable. Miriam?
Okay, I'm going to talk the arguments that are passed by value and reference. So a value argument is a primitive argument, and the actual value of the primitive is passed and copied to a corresponding perimeter value, and we have that as in our example as 365,000. And then a reference is an object, and so the location of the object in the memory is passed and copied as we go throughout our program here. And it's important to know that objects are not passed by value. And so that's the difference between those two arguments.
And also you can see in this example, the highlighted in yellow, time, people, and required are all local function variables. And this .resource type is a class level variable passed by reference.
And this concludes our midterm presentation for CIT260. Thank you for viewing.
Woohoo!